Welcome to the 22nd lecture on computational mathematics with SageMath. In the last lecture, we looked at computing integral of various functions using SageMath, including some numerical integral wherever it was necessary. So, in this lecture, we will look at two things. One, we will look at what is average value of a function, and secondly, we will look at how to find improper integrals. So, let us get started. So, if you look at the average value of the function, if you are given a function f(x) is equal to some function y equal to f of x, some function in interval a b, then how to find the average value? If you recall, the average of set of values or set of numbers one finds using adding all of them and dividing by the total number of the points, right. So, the idea of finding average value of integral is also very similar. So, instead of adding these values in case of individual points, you integrate the function, that means find the area in that interval and divide by the length of the interval. That is what is called average value of the function. So, this is how we calculate. Of course, we need function to be Riemann integrable, then only this integral will make sense, we can find the area. So, for example, if I look at a simple problem, a car travels with velocity y is equal to 40 plus 10 between t equal to 0 and t equal to 5. If you have to find the average velocity, then what will you do? You will just integrate this function between 0 to 5 and divide by the length, the time interval, which is 5. So, that is how we calculate. Let us calculate this using Sage. It is quite simple. So, define t as a variable, a and b as 0 to 5, this is the velocity, and the average velocity is 1 upon b minus a into integral of vt with respect to t from a to b. And if you print, this is what you get. 20 is the average velocity when the car is traveling using this velocity. Similarly, let us look at another problem. So, suppose you have a room which temperature is 25 degrees Celsius and keep a cup of coffee at 90 degrees Celsius. Then according to Newton's law of cooling, suppose at t minute this temperature of coffee is given by 25 plus 80 into e to the power minus t by 40. Then what is the average temperature of the coffee during first 20 minutes? Right. So, how do we calculate? Again, it is quite simple. So, if you look at this function of cooling function as a time, define that as capital T and then calculate the average value of this capital T between 0 to 20. Right. So, that is the 87.955 is the average temperature, which is quite high. Right. So, it simply means that within 20 minutes if you drink this coffee, it will be quite hot, right. Similarly, there is another important result on average value of the function, and it says that if you look at the average value of the function in the interval a to b, then this is equal to f of c, that is, it is attained at some value c between a and b. This is what is called mean value theorem of integral. So, let us look at geometrically what it means. So, suppose you have function f(x) is equal to sin x into e to the power minus x square in the interval 0 to 2. Let us plot graph of this function. So, that is the graph of this function, e to the power minus x square into sin x, and if you look at the average value, if you calculate the average value, this is equal to 0.210. So, if you draw a horizontal line at 0.210, then it will intersect this function about at 2 points in this case. So, that is the meaning of this mean value theorem of integral. So, let us calculate this value is, let me store that value in m. So, though I have written here numerical integral, in this example you do not need numerical integral, but if you have complicated function you need to calculate the numerical integral. Now, let us look at what will be the intersection of the function along with this. So, first let us plot graph of the function along with the the horizontal line y is equal to m with red in color. So, you can see here this is the rectangle of height m in this interval. So, that will intersect, this horizontal line will intersect at 2 points, and we can find out this using find root command. So, this find root of f of x is equal to m between 0 to 1. So, you can see that there is one root between 0 to 1, there is another root between 1 and 2. So, the first root I am calling at C1, which is 0.2231, and the second root is C2, which is 1.2231, and so if you try to plot both together, then this we have already seen, this is how it looks like. So, that is the geometric meaning of the average value of the integral, which is attained at some point of the function. This is what is called mean value theorem of integral. Right. Now, let us look at improper integrals. So, if you have integral f x from a to infinity or minus infinity to b, a and b are finite number, or minus infinity to infinity. So, this kind of integrals are called improper integrals. So, improper integrals in this case is one in which either one or both the limits are plus infinity or minus infinity. You can also have a situation where the function at some intermediate point a or at the end point may shoot to plus minus infinity. Such integrals are also known as improper integral. So, one can define when does this kind of integral exist. One can define this integral using limit. So, for example, if I want to define integral of f x from a to infinity, generally one finds integral from a to t f x dx and take the limit of that as t goes to infinity. If that limit exists, we say that this integral is convergent, and the value of that limit is the value of this integral, right. So, Sage can find improper integrals, but not everything. Of course, it has limitations. So, for example, if you look at f x equal to sin x, and if you try to find indefinite integral from 0 to infinity, then it says it is undefined. For example, in this case, because this sine integral will integral of sine from 0 to infinity will go to infinity. Whereas, if you look at integral of sin x log x upon x from e to infinity, then this again it says that if you come down this error, they say that integral is divergent. So, in case the integral does not exist, it may give you integral is divergent, or it will say undefined, right. So, let us take one example. So, if you want to find this indefinite integral from minus infinity to infinity of 1 upon 1 plus x square to the power 3 by 2, then what do we get? So, first let us plot graph of this function between minus 10 and 10. So, if you plot this graph, this is how the function looks like. Let me make it figure size small, so that it will be visible properly. Fig size is equal to, let us say, 3, right. So, this is how the look like. So, you can see here after a certain stage this function is almost very close to 0. So, what matters is the area in this finite domain, rest can be made as small as possible. So, that gives you an idea that this indefinite improper integral exists, and if you try to find out this improper integral, the answer is 2. So, this is convergent. Similarly, if you try to look at integral of log x square from minus infinity to infinity, first try to plot graph of log x square. So, if you take log x square from 0 to 1, this is how it looks like. So, at 0 it goes to infinity, but that is log 0, log very number very close to 0 will be quite high in negative, very small quantity in negative, and then it's we are taking square of that, that will be very large positive quantity, right. So, if you try to find the integral of f between 0 and 1, this is 1, this is equal to 2, whereas if you try to, so okay, we wanted to find between 0 let us find from between 0 to infinity, not from minus infinity to infinity, from 0 to infinity, and then see what you get. So, this one, let us calculate from 0 to infinity. Infinity is 0, this value you can see here, again this is, this says it is divergent. So, it is divergent, whereas in 0 to 1 it is finite, right. Let us take another example. So, for example, this integral of cos x square from 0 to infinity, again this value is equal to square root pi into square root 2 by 4, and if you try to find numerical value of this, then dot n, this will give you 0.6266. So, that is the numerical value. So, this is convergent and its value is 0.62. Similarly, if I look at this function, so this function for example is not defined at 1 and it also not defined at minus at 0 and minus 1. So, if you try to plot graph of this function between, let us say, first let us try to plot between 0 to 10, then you can see here it gives you some error that there is domain error at point close to very close to 0 and 1, which is a problem. So, this is how the graph looks like. If you change the domain, so if you change the domain, for example, let us say 1 to 10, then at 1 again it goes to infinity. I have restricted the y range to 10, you can make it, let us say 100. So, in that case, this is how you can see, right. So, if you try to find the integral of this, what is the function? The function is 1 upon x into square root x square minus 1. The integral of this between 1 to infinity, this value is pi by 2, and the same integral between 0 to 1 that does not exist. So, that does not exist. So, you can see here again this integral is improper integral, because at 1 it has the function goes to infinity, and at also 0 the function goes to infinity. In fact, it is not defined there. So, these are called improper integral, and many times, I mean, if the improper integral exists, then Sage will be able to find. One of the application of improper integral you must have seen is called beta gamma function. So, how does one define gamma function? Let us see. So, suppose you define x and n as variable, and we will think of as integer, or it can be any positive number. So, if you take integral of e to the power minus x into x to the power minus n, x to the power n minus 1 x, this is minus gamma n x, whereas if you assume n to be positive and calculate this integral, this is what is called gamma of n. So, gamma of n is defined as integral from 0 to infinity, integral from 0 to infinity of the function e to the power minus x into x to the power n minus 1. This is what is called gamma function, gamma of n. So, and this is actually this one can think of as generalization of factorial function. So, for example, if you look at what is if you try to plot gamma function, this is how it looks like. Let us plot in smaller domain. So, 0 to, for example, let us say 1 to 6, sorry, this 1 to 6. So, gamma function is inbuilt in SageMath, though we defined. So, here it is, there is no problem, whereas if you try to define between 0 to 6, then you will see that at 0 it will go to somewhat infinity, and if you look at from minus 3 to, let us say 1, then you will see that at negative integers this gamma function is not defined, and so if you try to restrict the y range, let me say y max is equal to say 20, and let me also say fig size is equal to, this fig size is somewhat slow, so 1, which is fig size is equal to 4, y min also I will say, y min is equal to, let us say, minus 10. Yeah, so now you can see here, the except at negative integers and 0, the gamma function is defined, and this is how it looks like. Right. So, if you look at what is the value of gamma 7, what is value of gamma 7? This is 720, which is 6 factorial. If I look at what is value of gamma, let us say gamma 5, this should be 24, which is 4 factorial. So, in fact, if n is integer, then gamma n will be n minus 1 factorial. You can verify this. So, gamma of p is it equal to factorial of p minus 1 for any value of any integer, positive integer p, right? This is true. So, that is why we say that gamma function is generalization of factorial function. If you look at what is gamma of half, this is square root pi. So, and so what will the square root pi? It will be n is equal to half. So, e to the power x into x to the power minus half, that is 1 upon square root. So, e to the power x upon square root x, if you try to integrate between 0 and infinity, this you will get as square root pi. That is very important approximation. So, that is what is done here. Square root e to the power minus x upon square root x will be square root pi, which is gamma of half. And gamma of x plus 1, if you try to simplify, you can use change of variable, then that is nothing but x times gamma x. So, you can verify this. Boolean means it will give you true or false value. Without Boolean, it will not give you, it will simply return this is equal to double equal to this, right. Similarly, if you take the derivative of gamma function and try to calculate what is the derivative of gamma function at 1, this gives you negative 0.577, which is negative of the Euler gamma constant. This is what is called Euler gamma constant, again very important constant. Okay. Next, if you look at integral of t to the power x minus 1 into 1 minus t to the power y minus 1, where x and y are positive and t between 0 and 1, this is what is called beta function. So, this is beta of x y, and beta x y actually is a function of gamma function. So, beta of x y is equal to gamma x upon gamma y divided by gamma of x plus y. So, that is what is verified here. Beta of x y is equal to gamma x into gamma y divided by gamma of x plus y. So, and this beta gamma function has lots of application in statistics. Okay. Similarly, if you look at take any book, try to look at what are the some of the properties of beta gamma function, you can very easily try to verify in SageMath. At the end, let me leave you with some simple exercises. So, first two exercises are to verify this the relationship between the average value and the value of the function, or mean value theorem for integral. So, take the function f x equal to x upon 1 plus x square to the power whole square in the interval 0 to 2 and verify this mean value theorem for integral. You can also plot the rectangle as we did in above. Similarly, you take the second problem is the linear density of a rod 12 meter long is 18 upon square root 2x plus 1 kilogram per meter, where x is measured in meters from one end of the rod. Find the average density of the rod. So, this is okay, and then try to evaluate these improper integrals and the fourth one is if you look at this function, for example, f x equal to this 1 upon square root 2 pi s into e to the power negative of x minus m the whole square upon 2 sigma square. I should write 2 s square, not sigma square. So it is s square. You can take sigma also. So this is what is called Gaussian function. What happened? Gaussian function, and try to plot graph of this function. This will be bell shaped graph around m. M is the mean, s is the standard deviation, and try to find this integral from minus infinity to infinity of f x from of f x. So this will be the total area from minus infinity to plus infinity, and this turns out to be 1. So that is why this is a probability distribution function, because the area, total area under this curve is 1. Okay. So thank you very much. Next time we will look at some applications of these integrals.